Okay, so what we're going to be doing is we are going to go over a few questions from the 6.13 before we start the 6.14. So I'm just going to start with number 1, sine of 45. So sine of 45 degrees, all you have to do is you're going to look at your unit circle. Now the main takeaway is on your unit circle, there's going to be a coordinate for each value, and it's always cosine comma sine. So cosine is always the x, and sine is always the y for that coordinate. If you want to find tangent, tangent is just sine divided by cosine. So with that information, you can find any of those trigonometric values using those rules. So if you were to look at your unit circle, whether you have it out or not, at 45 degrees, the coordinate is radical 2 over 2, radical 2 over 2. So therefore, sine of 45 is radical 2 over 2, because it's the y coordinate at 45 degrees, okay? Then we're going to look at cosine of negative 45 degrees. So anytime that you have a negative degree measure, you always want to convert it into a positive coterminal degree measure by adding 360 to it. So I added 360 to negative 45, and then I'm going to look at my unit circle at 315. And if you look at the unit circle at 315, whether you have it out or not, the coordinates are radical 2 over 2, comma negative radical 2 over 2. Since it's cosine, it's going to be the x coordinate, which is radical 2 over 2. So you just have to know x is cosine, sine is y, tan is sine over cosine. And then the next one, tan of 60, we'll do a tan one. So when you have tan, you're going to convert it into sine of that angle measure over cosine of that angle measure. Well, sine of that angle measure is, according to the unit circle, radical 3 over 2. That's the y coordinate at 60 degrees. And then cosine is 1/2. So when I have a fraction divided by a fraction, I would do keep, change, flip. So it's going to stay as radical 3 over 2. It's going to change and become 2 over 1. These 2's are going to cancel, which leaves me with radical 3 as my answer. So in the calculator, if you were to do tan of 60 degrees or do radical 3, they would come out to be the same answer, so you could check your work. So does anybody have any questions about that? All right, if you want more details, of course, there is the video up with all of that information in there. But I just wanted to give you like a little idea in case you hadn't had a chance to see it yet. All right, so now we're going to proceed with our notes for 16.4. So if you can all have those 16.4 notes out, those are the ones I just handed to you. We're going to talk about standard position of angles, quadrantal angles, all that stuff. So a quadrantal angle is an angle that falls directly on one of the quadrants. So there's really 4 types of these. There's the one that falls at 0 degrees, meaning you basically didn't move at all from the initial side. 90 degrees, which falls right on the y-axis, the positive y-axis. 180 falls on the negative x-axis, and 270 falls on the negative y-axis. Now, you're going to see problems where they're going to ask you to find all 6 trigonometric values given this information. So I'll talk you through how we would deal with one of these problems. So in the problem that we're looking at, let's read what it says. It says, find the exact values of the trigonometric functions of theta. So what we're going to have to do here is we're going to have to use something called a reference angle. So a reference angle is an angle that is within this triangle in that quadrant that will help you find the information regarding this entire angle. So the reference angles will always form that bow tie shape that we talked about when we did the unit circle. So does everybody see how when I did that angle, I created a triangle in the 3rd quadrant? So we're going to use that angle or that triangle to find some information. Now I know that distance can't be negative, but we can make distance negative to signify the direction that we went in, okay? So what would be the distance, the horizontal distance here according to this point? -3. 3 units, but it's in the negative direction. And what would be the vertical distance here? -4. Now, could I find this side here, r?
Yes.
Yeah, because this is not the unit circle, so r is not necessarily 1 here. How could I find r?
Pythagorean theorem.
Pythagorean theorem. -3 squared plus -4 squared equals r squared. That's 9 plus 16 equals r squared. That's 25 equals r squared means r equals 5. So everybody see how I got 5 there. Now they want to know the trigonometric values. So what we would do is, this is basically our sub theta. I'm just going to call it theta with a little 1 there to indicate that it's not the actual theta we're talking about, but is a reference angle for theta. We're using it to reference what theta is giving us. So sine of theta would be opposite over hypotenuse, right? Opposite over hypotenuse. Everybody see how I got that? Cosine would be what? Adjacent.
Adjacent over hypotenuse.
Thank you. Adjacent over hypotenuse. And then tan would be
Opposite over adjacent.
opposite over adjacent. So notice I found 3 trigonometric values, but the question didn't ask for 3, it asked for how many? 6. So these are what we would call the reciprocal. We talked a little bit about these very briefly in 6.1. So that's cosecant.
For tan, should it be a -3 on the bottom?
Yes, thank you. Good point. I almost forgot about that. So a negative divided by a negative means the whole thing becomes
Positive.
positive. Sorry about that. So cosecant, secant, and cotan. These are what we would call the reciprocals of the trigonometric functions that you're used to working with. So sine is the reciprocal of cosecant and vice versa. Okay. Cosine is the reciprocal of secant, and cotan is the reciprocal of tan. So reciprocal, what do we do when we take the reciprocal of a fraction? Flip it. But we don't change signs because that would be opposite reciprocal. So this would become -5/4. The 4 is the one that's negative, but you don't leave negatives in the denominator of a fraction, so you just bring it up top. What's the next one going to be? -5/3. And then lastly? 3/4. So that is how you find the 6 trigonometric values given a point on the side of a angle. Now we're going to look at something a little different. We're going to look at measuring angles in standard position given points. So what this basically means is, if you have a point on the coordinate plane of any type, you can find the angle which would give you that point opening up, okay, with using trigonometry and our rules about it. So first thing I want to look at is the angle. Did I open clockwise or counterclockwise?
Clockwise.
Clockwise. Therefore, I know my final answer is going to be what?
Negative.
Negative. So keep that in mind as we go through the problem. Now, I'm looking at this angle, and this is one of these things. There's no like specific rule I can teach you to follow every time. You have to use intuition and logic to figure these problems out, okay? What I notice is I can form a triangle right here to find theta. And if I find theta, how could theta help me find this outer angle here? I could subtract from 180. You see that? So if I can find theta, I can subtract from 180 to find this value. Make sense? Okay. So with that information, I know that this is -2 and this is -2 because that's the vertical and horizontal distance, right? Now, I don't really need to know what the hypotenuse is. You could find it using Pythagorean theorem, right? But really, what the question I'm going to need to know is, I'm going to need to know what theta is. So I don't have the hypotenuse, but I have the opposite and the adjacent. So what trigonometric function would help me here? Tangent. So if I do tan of theta equals -2 over -2, that's tan of theta equals 1, right? Now, there's 2 ways you can do this. You can strictly use the calculator. Do you remember what you can do to find the value here with the calculator? Use the,
Reverse.
yeah, the inverse button, right? Tan inverse of 1 equals theta. Now, make sure your calculator's in degrees or it's going to give you a decimal. But if you do that math, anybody want to tell me what you get? 45. So theta equals 45. Now that would be a sufficient way to do this. But keep in mind, what you could have also done is you could have looked at the unit circle as well. So I'm going to drag over a unit circle. I just Googled one so I could show you. So if we look at this unit circle right here, okay? If I look at 45 degrees, do you guys see 45 degrees right here? If I look at 45 degrees, I see that this is radical 2 over 2, radical 2 over 2. Over here at 225, this is negative radical 2 over 2, negative radical 2 over 2. What is negative radical 2 over 2 divided by a negative radical 2 over 2? 1. That's tan of this angle, which is how I got it. So just keep that in mind. It does relate to the unit circle, but you can use the calculator to find it. So now that we know that this angle is 45 degrees, how can I find this angle here? Yeah, 180 minus 45 equals 135, but it's going to be negative because I went clockwise. Does that make sense how we got that? Okay. So you could have technically done this one without using a calculator because of the using the unit circle. All right. Now what I also noticed about this is a right triangle because I made it one, but it's also a isosceles. And when a triangle is right isosceles, the angle measures have to be 45, 45, 90. If the angle is 45, I know it's the 45 angle in that quadrant, which is 225. And then I could find the sine, cosine, and tangent. All right. As for the next one, I know that I can find this angle a few different ways. There's really a few different ways that we could find it. But what I do know is, yeah, that's the one that comes to mind first, but I think this one would make more sense. You always want to use the bow tie shaped triangles. So if I find a triangle right here, I could then do 180 plus that angle to get this whole angle, correct? So that's what I'm going to do. Now this angle right here, this distance is -1, and the horizontal distance is what? Negative radical 3. This is going to be some kind of 45-60 triangle, but it's not that important here. I have the opposite and the adjacent, so I should use what? Tan of theta equals opposite over adjacent. So really that's just tan of radical 3, right? So then I can use the inverse. And this is actually one of the exact values that we did earlier. Anybody know what it's going to be? Theta equals 60.
Oh, yeah.
You remember how we did it earlier?
Yeah.
We're just undoing it, basically. So you could use the calculator or you could use the unit circle to figure this out. So now that we know what the angle measure is, that's not the answer to our question, right? We wanted to know this entire angle, this whole thing. So what direction did we go to get that angle? Counterclockwise, so I know my answer is going to be. So it's going to be 180 plus 60, which is 240 degrees. Everybody see how we got that using that information? All right. So the last thing we're going to do today. Oh wait, we got one more thing to talk about. This right here is just basically describing to you what a radian is. A radian is a type of measure for an angle. And it basically just identifies the fact that if we take a unit circle, the radius is 1 unit. And if we lay that unit down on the side, we create a radian. And then the last one just is reiterating the point that cosine is your x-coordinate and sine is your y-coordinate. If there's one thing you remember going into this test other than the unit circle, you need to know that cosine is x, sine is y, and tan is sine over cosine. You cannot do this test or quest, whatever you want to call it, without this information. Very, very important information. Commit it to your memory. All right. So the last thing you guys are going to do today, your homework, you're going to have a whole homework day tomorrow because it's a Delta Math day. Oh, wait. I keep wanting to speed forward. We still have one last thing to do. Sorry. So we're going to find the cosines and sines of the quadrantal angles. So when you're working with a quadrantal angle, you're going to draw it in. So we have our initial side, and we open up 90 degrees. If we're opening up 90 degrees, what is the coordinate of the unit circle up here? 0, 0, 1, right? Because it's radius of 1. So we know that cosine will be what? Cosine is the one thing I said to make sure you always remember. Cosine is x. Sine is... Well, sorry that we can't hear everybody in here at the hall.
Why is sine?
Yeah, sine is going to be 1.
Yeah. That's fine.
All right. Next one is negative 180. So notice that I opened clockwise because it was negative, but it's going to be the same thing as regular 180. So what is the coordinate of this point right here? Negative 1, 0. So that means that cosine is good, and sine is 0. And then lastly, we have 270. 270 we open all the way around. What is the coordinate of this value down here?
1, 0.
0, negative 1, right?
Yeah.
So that means that cosine is, and sine? Negative 1. So the way I remember cosine is x, sine is y, is because cosine comes before sine in the alphabet, just like x comes before y. Yes?
Can you go back to the 90 degree?
Okay, so what is 0 equal? Just 1, 0, right?
I was just going to explain, wait, what?
Like 1, 0 as like the coordinate for just
Oh, yes, yeah. Just think of it as the coordinate of a circle with a radius of 1. Now, there is one last thing I want to talk about real quickly. If I wanted to find tan, tan is sine divided by cosine, right?
yeah.
Can you divide by 0? So tan in this case is undefined. But in this case, it would be 0, because 0 on the top's okay. 0 on the bottom's bad, right? Tan of at this one would be 0, because it would be sine over cosine. But tan at 270 and 90 would be undefined because it's where cosine is 0. Anytime cosine is 0, tan is undefined because it gives us 0 in the denominator. So if you were to graph tangent, it would have asymptotes at those values infinitely. So your last task of the day, other than if you want to start your homework early, I want you to try to fill out this unit circle as much as you can without looking at your pink sheet. Okay, I'm not going to test you on that or anything, but your goal right now is to do that because you are going to have to do that on your quest, and we are